Everyone, and welcome to the last lesson of activity 32. Today's lesson 32.2 starts on page 467 in your Springboard books. You're definitely going to want your book, your pencil, a calculator, and a sheet to keep track of the formulas. Today we are going to focus on finding the area of a sector and the arc length of a sector. A reminder that a sector is a piece of the pie, or a piece of the pizza, as I like to say, and it's just basically a fraction of our circle. So if we go back to talking about this garden that we had from the last lesson, notice this garden is being cut into 8 equal sections, and basically each of the sectors are representing 1/8 of the entire circle. Now, a reminder that from the last lesson, the diameter of this circle is 20 feet, which means the radius is 10 feet. And the total area that we find by taking pi times r squared is going to be 100 pi, or that comes out to be approximately 314.2 square feet. Now, what if we only want, though, 1/8 of this, right? What we would have to do is take that 314.2 and divide it by 8, or multiply it by 1/8 is the same idea. And what we would see is if we take that 100 pi, or 314.2, and again multiply it by 1/8, we get that fractional value of 39.3. So basically what we're seeing here is that each of our sectors is about 39.3 square feet. Now, if we look back up here at the circle, we talked a lot earlier in the year about how the central angle of our circle is equal to its arc measure angle degree-wise, okay? And in this case, if we have 8 equal central angles, and we know that the whole circle has 360 degrees, if we divide that by 8 or multiply it by 1/8, each of those angles come out to be 45 degrees, right? Now, 45 degrees, if we think about it as a fractional part of this circle, 45 divided by 360 is, if we make this into a reduced fraction, 1/8 of that circle. So there's that comparison between the degrees and the that fractional value. And what we see here is, again, this is the measure of the central angle of one sector. And we know then that that 360 represents the total degrees in our circle. So there's that relationship happening between them. So basically what we're seeing is that this fractional value, the angle measure over 360, if you multiply that value by your overall total area, you're getting the area of that one singular sector. So that's where the area of a sector formula comes from. We take that central angle measure divided by 360 degrees and multiply it by pi times your radius squared. So you definitely are going to want to have written down now this formula for area of a sector. Now, just like we took the fractional value of our total area, we can also take the fractional value of our circumference. So again, think back here to what we talked about the other day. The circumference is this entire perimeter around our circle, if you will. Well, what if we just wanted a fractional value of that, a fraction of the circumference? Well, that's what arc length is. Again, you want to think about it as a fraction of the circumference. Okay? And what we'll see then is that the arc length formula is representative of that, right? And so the arc length formula is going to again relate to that angle measure over 360 degrees, this time times the circumference 2 pi r. Or you might see it represented as if you're giving you the diameter, the angle measure over 360 times pi times diameter. Okay. So for that last example that we talked about, if we're looking for the arc length of that particular circle that had a 45-degree central angle, and we said that the radius of it was 10, to find the arc length, we would take 45 divided by 360 and multiply it by 2 times pi times our radius. So that would be angle measure divided by 360 times 2 times pi times that radius of 10, so that our arc length would be about 7.9 feet. Okay? And again, arc length is not going to be squared, just like circumference isn't. Okay, so we have a couple more examples dealing with this. This time, let's talk about a circle. Let's find both the arc length. It only says area of the sector, but let's also find the arc length of a sector that has a 36-degree angle and the radius is 5 inches. Okay, so let's start by finding the area of this sector. A reminder that is angle measure divided by 360 times pi times your radius squared, right? In this case, our radius squared is 5, and we said that this angle measure is 36 degrees. So we're going to take, we'll use Google's calculator. So we're going to take 36 divided by 360 times pi times that radius value squared, which we would square using this piece here. So set caret there. We get that 7.9. And again, this time it's going to be feet squared, since this is dealing with the area. And then if we want to find the arc length of this particular one, it didn't ask for it, but just to have some practice with it, the arc length this time is going to be found by taking, again, the angle measure over 360 times 2 times pi times the radius. Okay? Now this time, again, our radius is 5, and that angle measure was 36. So again, going back, 36 divided by 360 times 2 times pi times that radius. It's about 3.14 ironically. So we'll just say 3.1 if we're rounding to the nearest tenth. This is just feet. Again, notice area squared, just length, feet. Okay. And that is what we have for today in solving the arc length and the area. One final type of question you might see, and we're going to work a little bit backwards here, is one like number 10. This time, this is kind of a challenge question for the end, is we have the length of an arc, and they're giving us the diameter, and they actually gave us the length of the arc this time. So we said from before that it's going to be the length of our arc is going to be the angle measure divided by 360 times 2 times pi times the radius. Well, if the diameter is 10, the radius is 5, and again, they gave us the length of the arc this time. They're telling us what this is. So if we start plugging this in, we have 1.25 pi, and we know that that's going to equal that angle measure over 360, and then times 2 pi r, which we said is 5. Well, something cool that's going to happen is since there's a pi on both sides, they will cancel out. 2 times 5 is 10. And then we are going to multiply it by the angle measure over 360. Well, we want to get the angle measure on this one. So what's going to happen is we're going to have to multiply both sides by 360. So we would end up with 360 times 1.25. And then to get the angle measure by itself, we'll end up dividing by 10. So we're going to take, again, 360 times that 1.25 And then we're going to divide that by 10, and we get a final angle measure of 45 degrees. Okay? So this is kind of like a challenge type question, is what number 10 is asking you for. Okay? All right, everyone. Thanks for watching. Congrats on finishing up Unit 5, Part 1.